This video is on solving equations that have squares or that have square roots. So equations with squares and square roots. So just with any other equation, or just like any other equation, the first thing you're going to want to do is to isolate your square or your square root. Now these are called radical numbers, but we do want to isolate them. So it's the equations that we've been working on all year. We use the same steps to isolate. Then we have inverse operations for our squares and square roots. So if I have x squared, the inverse operation, in other words the operation to undo the square, is finding the square root. So the inverse operation of squared is the square root. That's going to give me x. If I have the square root, the inverse operation is to square it. This will give me x. So we have to remember these two facts. The inverse operation of squared is to find the square root, and the inverse operation of the square root is to find the squared. Okay? So what this means is that if we had the x underneath the square root of x equals 9, we're going to use the inverse operation of square to undo the square root. And remember, what we do to one side of the equation, we must do to the other side. So I'm going to square both sides of the equation. This is going to undo the square root, leaving me with just x, and then 9 squared is 81. If I am working with squared, I need to use the square root in order to undo the square. So x squared equals 9. If we want to know what x is, we have to use our inverse operation of using the square root. And what we do to one side of the equation, we must do to the other. So I'm going to find the square root of both sides. Over here, that's going to undo my square and leave me with just x. And then the square root of 9 is 3. So let's look at some examples. Example A is the square root of x equals 10. So in this one-step equation, we're simply going to use our inverse operation of square, and what we do to one side, we do to the other. So this square undoes our operation here of the square root and leaves us with x, and then 10 squared is 100. And we can check our work, right? If we say, well, what is the square root of 100? It's 10, right? 10 equals 10. So this does check out as a solution. All right, our next example, x minus 2 in our square root equals 3, okay? Since x minus 2 is all contained within the square root, then we're going to want to undo that operation by squaring both sides. All right, when we do this, this undoes the square root, leaving us with x minus 2 equals, and then 3 squared is 9. Now notice we're not finished. We're still trying to solve for x. So now we need to use the inverse operation of addition to undo our subtraction, and we're left with x equals 11. And again, if we come back in and check our work, right, we have 11 minus 2 equals 3. Well, 11 minus 2, square root of 9, equals 3. And 3 does equal 3. So that checks out, and that is our solution, x equals 11. Our next example, alright, the square root of x minus 6 equals 7. So now only the x is in the square root. Again, going back to the very simplest directions of solving equations, we want to isolate our square root. So we need to add 6 to both sides, okay? This is going to undo this here, leaving us with just the square root of x equals, and then we have 13. Now we're going to use the inverse operation to undo our square root. So now we want to say squared, squared. This is going to undo the operation of the square root, leaving us with just x. And then 13 squared is 169. So x is equal to 169. Alright, in our last example we have a squared. So going back to those very basic rules, we want to isolate our x squared first. So subtract 5 from both sides. So x squared is equal to 36. Now we want to use the inverse operation to undo this square, and that is to find the square root of both sides. So the square root will cancel out the square, leaving us with just x equals, and then the square root of 36 is 6. So x is equal to 6. And if we plug this in to our original equation, 6 squared plus 5 equals 41. 6 squared is 36 plus 5. And 41 does in fact equal 41, and so that solution checks out as well. X is equal to 6.